Okay, today our lesson will be inverse of linear relations. So we can have inverse of linear, inverse of quadratic. So let's take it one by one. Inverse of linear relations. So first of all, let's see a function in a set. So if I have a function f x, if this function is a set of 3, 1, 2, 6, 3, 9, and 4, 12. This is a set. So let's see the domain here. The domain is the x values, which is 3, 2, 3, we have it again here, and 4. Okay, let's do this one, not to be confused with 9, 3. Okay, 3, 2, 9, and 4. And the range will be the values of y. The values of y are 1, 6, 3, and 12. Okay, so this is the function, the given function. So to find the inverse of this, inverse means exchanging x and y. So we say the inverse, and the symbol for inverse is f minus 1. F minus 1 is exchange x and y, 1, 3, 6, 2, 3, 9, and 12, 4. And the domain of this is 1, 6, 3, and 12. And the range would be the values of y, which are 3, 2, 9, and 4. As we notice here, the domain of the function is, what do we do here? 3, 2, 9, 4. And then we see here, the range of the inverse is 3, 2, 9, 4. Therefore, what we say is, domain of function is range of inverse. Range of inverse. And the range of function is the domain of the inverse. So that's as simple as that. The inverse and simply the exchange the domain and range. So when we say inverse, how do we say inverse? First of all, we said inverse is exchanging x and y. So on a graph, inverse is a mirror image of the original function. So if this is x, y, inverse of a function is a mirror image on y equal to x. If this is y equal to x, the inverse, let's say if it is 1, 3, 1, 3 is here. So this point here is the mirror image on the other side. The image is always 90 degrees. This is 3, 1. And this is 1, 3. So inverse is a mirror image on the line y equal to x. So everything should be, for 6, 2 would be 2, 6. Okay, so let's see an equation. Find the inverse of y equal to 2x minus 3, and the graph, okay, both relations. Okay, so to see this one here, to find the inverse, first we said if this is given, y is 2x minus 3, we say to find the inverse, interchange x and y. Interchange x and y means instead of y I write x, instead of x I write y. Then we isolate the y. We isolate the y means x plus 3 is equal to 2y. Then we have to find only the value of y. Y will be x plus 3 divided by 2. And we say this is the inverse. If this is fx, this will be f minus 1. As we said, the inverse is f minus 1. And this is not the same as 1 over f. So my inverse now, we have it here. So if I visualize the graph, xy, the original function is 2x minus 3, which means minus 3 is here, and 1, 2, and 1 to the right, because this is the slope. This is a graph of the original one. And then this will be x plus 3 over 2, which means that my intercept is 1 over 2, and the slope is 1 over 2 again, 1, and then 2 to the right. Okay, so this is image, which means that this is a mirror image on y equal to x. This is y equal to x always. This is always a mirror image. This is original one, this is inverse. This is f, and this is f, this is f minus 1. So if we have an exact graph, this will be a mirror image of this. This is my mirror, y equal to x. So if a relation is a function, then it's not necessarily that the inverse is a function. It can be a function if we restrict it. So we'll see in this case, the inverse is a function and the original is a function. Okay, that's all about the linear functions.